Here is one of the vertical gantry supports for the CNCs that I build. And what I'm after today is in this area here, this is the mounting section, the mounting holes for the NEMA 24 stepper motors that goes on the side. So what you're looking at is there's the hole for the motor shaft, of course, and this is a recess. The NEMA 24s have a little bit that sticks out, so we recess that in. And then the 4 mount holes, which are here, 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 and over here. If you follow that in the tree, we have, let's see, pocket 9, pocket 8. The original pocket is pocket 7, and then down here there's a circular pattern that goes around that creates the rest of the holes. All right, so here's the problem. This is a common feature. The NEMA 24 hole pattern is a common feature in things that I might build. If I'm going to stick a motor onto something, I'm going to need to have this same thing. I don't need all the rest of these holes. I don't need these lines. I don't need all the rest of this stuff down here, but this is common. So it would be nice if we could save this. If I could make a stamp out of that feature and I could just stamp it into any product that I make where I need to mount a motor to, that would be great. To take it a step further, if I could take that and save it maybe in a catalog, that would be pretty cool too, but that's another topic. So today's topic is about power copies and how we can use them to do exactly this. So let's say we have a new piece right here that we're going to build up for some other device. Maybe this is, short, squatty little laminate cutter or something, but I'm going to need to have a NEMA 24 motor hole pattern placed right in here. So how am I going to go about doing this efficiently? I could flip over to the other one. I could copy out piece by piece, paste it in here. I'm going to have some problems. I'm going to have to, with sketches, you're going to have to redefine the sketch plane that it's on. The orientation might be turned a little bit, so it's problematic. So that's where power copies excel. So to get started first, we have to go make a power copy, and that's the critical key first thing, because some people don't understand. You got to go make it first, and then we can take it and we can apply it to all these other things. You don't just strip it out typically, right? You don't strip it out of the part that you already have. So we're going to go off to the side and we're going to make the whole pattern again, but we're going to make it on a plain device. It's essentially going to be made on a flat pad, and it's going to have all the features we need, but not necessarily look like any kind of thing that you would see this on. So to get started, I'm going to make the base of the power copy, but this will not be used in the placement of said power copy. In CATIA lingo, we call this instantiation. So I'm just going to make a new shape here, and this is going to be, I think if we just make it 100 by 100 millimeters, that will be fine. And then this becomes let's see what I want to do here. Let's make it 10 millimeters. This becomes the base and basis for the power copy itself. So right off the bat, to put the brakes on this whole thing, I want to explain what is the probably most critical piece of this whole power copy deal. And it's a thing that I've talked about a fair amount in some of the other CATIA videos and other just CAD videos in general. You've got to understand links. The way that one thing links to another thing, the things that you're doing inadvertently that are creating links to the part or other features that may or may not affect what you do in the future. Look back at a video on making bodies. They're talking about that. So for example, if I go here and I go to make a sketch right here, even before I get started, I just picked this face and I'm going into sketch. So now I've said that the support plane for this sketch is the top of this face, the top of this part right here. If I pick a plane, then it will be that plane, and that means something. Of course, it's a little bit of a, yeah, of course we get this kind of deal here, but you got to keep that in mind because that might be a big deal in a minute. So then we go into Sketcher here, and we go to make a feature. So we want to make the 9mm hole going through here. So you come over here like anything else, and you snap to origin here, and you pull out this circle here, and we go ahead and we make it 9 millimeters. The thing that you've just done already is, if you know, the circle part's fine, the diameter's fine, but you've made a link to origin by letting it lock there, and this is one of those hidden constraints, remember? So we have a constraint, and I can't really even look through the tree and find it and get rid of it. So that's a biggie right there. So when you go to place the power copy, here's what's going to happen. It's going to ask you what, it's kind of like mapping. If you've ever mapped a database to a table to a table, it's going to ask you, what does this face, you say this sketch is on this face, what face does this mean? And then you'll say, I want it to be this face of this new part. Then it'll say, okay, that's fine, but what is this origin? What is this center point here? What are you talking about there? And you say, oh yeah, that's this center point here. Now if you don't get this, if you don't do it correctly, then it might want to snap it, let's say, to the origin of the new part, and that's not probably going to be what you want. So we're going to back this up. We're going to get rid of this sketch, and what we're going to do is put our own point on this part, and we're going to lock it to that. Now this is where things are going to begin to get a bit more tricky. So I have to put a point on here. I can do it either in Sketch, or I could make a reference element point. It doesn't really matter exactly, but I need to know where to put it. So if I go into Sketcher and I put a point, I'm going to put a point here somewhere. Where do I stick this? See this right here? I don't want to stick it to that, because that means it's stuck to horizontal. I don't want to stick it to vertical. I don't want to stick it to origin. I don't want to put it over here and then start measuring off from there, because now I just said that I'm measuring it off a horizontal. Or maybe I do. So here's what I want. Let's look back over at the other part here. So I got them saved over here, the new shape. And let's say I want this pattern, you know, I want it here somewhere. So what's a good, if I were to have a point that everything is kind of tied to, what would I key off of? And one good thing might be just the top edge and the side edge. It could be origin. It could be the bottom. You know, so here's the bigger point to hold this thing, is you need to know where your power copy is coming from, what's going to be the most logical place to place it based upon maybe how the part works, or how people think about how the part works. So for this one, I'm going to say that the point is so far down from the top edge and from the side edge. So back in the sketch, I'm going to place the point right there, and I'll lock it to that edge. Remember, constraints off of edges of solids in the background. These are projections. They're kind of hidden-ish projected edges. So let's just say that this is the whole diameter, if you will, of this whole pattern is around 30 something. So let's just say that this is 50 down. This will actually we'll just place it in the center, but without locking it to origin. All right, there's my point. So now we can exit out. We have a point on the surface there. Now we can go about making the hole. You could use the hole tool if you want. I'm just going to go through and do it as a sketch. So we'll hit the top face here, and now I'm going to draw a circle, but you do not, this is good with a lot of different things, I don't want to snap to origin. I don't want to snap to the middle, but I can't select my point in there, so you make it off to the side. Super common thing to do. Turn it to the side, grab your center point here, and then constrain it like so. Now if you still can't tell if you're getting that point or not, go to the sketch in the tree, find your geometry, and make sure that you're selecting the point that you created, in the sketch before. So 0.3. So there's that right there. And I want to make it be coincident. So I'll exit out of here, pocket it down through up to last. Now, right there, we made another link up to last. So this is going to go all the way through. Now this is the shaft of the motor, and yes, we need it to go all the way through. What if the gantry side, what if we told it to just go down 10 millimeters, and then the thing that we're placing it on is maybe a 1/2 inch piece of aluminum stock? So you would have to change this value. It wouldn't go all the way through. So going up to last in this case is probably going to be your best bet. Keep it in mind though, because it's another link. So we'll go ahead and we'll make the circle on the face. Come over to the side here. If we want, we can throw on a diameter right now. If we look at the data sheet, it is 38.1 millimeters. So if we just went ahead, now you think about like how critical is this? Does it need to be really snug to it? No, it just needs to be bigger then. So I'm going to go ahead and say just 39. That should be plenty of tolerance for it to fit right. Then we'll anchor this to that original 0.3 again, make it coincidence. And then we will exit out and pocket it down. Again, the recess should be, the part that sticks out of the motor is 1.6 millimeters. So the recess here, we won't have up to last. We'll make it be a dimension. And we'll make it, we could make it just a little bit more, but I'm just going to say 3 millimeters. We could even make it go all the way through. Maybe it's just aesthetics. I'm not really sure, but I felt like I just want to have a recess there rather than just a big old hole all the way through. So we hit OK. Oh, actually, as a matter of fact, we cannot have a hole all the way through because, let me go ahead and do this, see, on the other side of this, we place a thrust bearing up against, a collar goes on the side here that goes up against a thrust bearing, and so, yeah, we wouldn't be able to have this. What we found out is the NEMA 24 stepper motors actually internally will shift back and forth maybe, I don't know, it felt like maybe a millimeter under force. So now we put a clamping collar on the side here with a thrust bearing right smack up against the face. So I'm going to make the first circle that we're then going to, we'll make it a hole and then we'll pattern it. Again, I'm doing it in Sketch. We could be doing it with the hole tool, but semi-irrelevant right now. So I have to put this circle down here, so I'm going to place it somewhere, but I need to know where this is going to go. And looking at the data sheet, unfortunately, they only have this listed as a dimension rather than a radial length. So we have to either do some math or we can do it a different way. Let's do some math. So this seemed like a perfect opportunity to do some review on the Pythagorean theorem in an applied fashion. So if we're looking at the sides here, the lengths that we have for the holes, we have 47.14 and we have 47.14 on both sides. So there is our two lengths of a right angle, and we need to know the hypotenuse. So in order to do that, we're going to come over here. We're going to say 47.14 times 47.14 times 47.14 equals 222 point whatever. So then we need to plus this time, that again, but I'll just say times 2 because that's okay. So now we get 4444.3592, and then if you look at the theorem, which I'll probably post up here somewhere, all we have to do is square that out, and we get 66.66666. So this is our 2/3 repeating, whatever you want to look at it that way. So the length from corner to corner is going to be 66.666. So if we want to do a radial, then we'll have no problem going from here. Whoops, let's click on the background first. Go from here to center, and we'll make it 33.333. Cool. But we want to make sure we pick that point. Do you need it out that many decimals? Probably not really. Now, another way you could do this, which is probably a little bit easier, and I don't know, maybe you can trust this a little bit better. If I take a centered rectangle and what the hell, I'll just smash it out. In this case, it doesn't matter that I'm picking center. So I bring this out, and then I'll make a dimension here, and of course this is going to be the 47.14, and then we'll do the same on the other side. And what we should find out is that this, if we move this around here, matches perfectly. We'll leave this here. I'll make this a construction element, and we'll see how far this is off so we can check our mathematicals. Now, as far as perfection goes, this is a repeating decimal, so CATIA has some sort of fudge factor in it. I forget what it is, but anything past like some, decimal figure, it calls exact. It calls on top of, even, I guess, right? So I guess we'll find out what that is. So anyways, we're going to make these a construction element. And then we have to put this at an angle. So this brings us to our next issue here. Our next problem is, what is this all going to be based off of? So to get this started, I am going to make a line first from here to my point that I made back here in sketch 3. You got to be careful here. You probably won't, like if I go to try to snap from here to here right now, guaranteed that's origin. So what you're going to want to do, turn this to the side here. I'm going to grab sketch 3 and I'm going to make a projection of it first. So I'm going to project this forward as a construction element. So I have that. So down in there somewhere is the little point, but I can snap to it, but I might still be snapping to origin. So I want to make certain that I'm not getting a hold of that. So what you want to do is hide all of your lines here. So I'm going to hide the absolute axes back in sketch 3 just to get that out of the way. So there's that gone. Now if you go to sketch 9 here where the circle is, if I hide the absolute axes, I'm not sure why this is, but if I hide it, it's still there. So you have to pick each one of these and hide those. Now those are gone. Now I can see my projection kind of inside there. So now we grab a line, construction element, grab the center point here, and then snap to that there. So that gets us that. So problem 1 solved. Flatten this back out. Now I need to get a line going here that I can create an angle off of, but it cannot be based on anything horizontal vertical. It's got to be its own freestanding line. So we're going to have to get out of sketch here and have to take a look at this. So here is our part. There is our point back here, sketch 3. And now we've determined that we need a line to build an angle off of. So we have to take a look at our main part, or the parts in the future that we don't know of yet that we think we're going to be making possibly, and figure out what's going to be a thing that we could take a direction off of. Could we take it off of one of our planes? Our planes will always exist, so maybe that's an okay thing. So let me give you an example here. And I understand that this is probably a little bit weird since we haven't actually made a power copy yet. Once we do this, you'll see why I'm going through all this effort, and then I'll review everything again. So I'm going to make a line here, and I can pick this point as my starting point, and then I need a direction, and oops, let's go point and direction. So like I said, this is where I got to figure out what this is going to be. So we just need something to base this angle off of. So for example, if you need an angle off of the floor, then maybe the floor is the thing you're going off of. If it's something that people typically measure off of a wall, then maybe the wall is going to be our direction. As in, maybe I'll choose this side edge right here. Maybe I'll choose this line. Maybe I'll choose down here. Maybe I will choose the plane. So think about this. Watch the video. Get done, see where we're going, and then come back and watch this again possibly, so you'll know what my dilemma is better at this point. So I'm going to pick this. Actually, I would have to pick this line because I can't pick that face there. So I'll pick this line, and now the direction of this line that I'm going off of is based upon the direction of the side edge of the gantry plate. And if you want to do both sides, if you want to make it infinite, that's fine. I'm just going to go ahead and make this, that's good enough. I'll just leave it like that. All right, so now we have a point and a line, but another small problem. As you go through this, and you're starting to make more and more features that are reference geometry, somewhere along the line you might go, you know what, this should all be in a geometrical set. Watch my videos on that. So you might decide that I want to insert the geometrical set And we can call it, you call it whatever. You can leave it blank if you want, call it reference elements or what have you. I'll just leave it blank. I'll insert that here, and then you start deciding, I want to move all my reference elements in there. If I would have known where I was going in the very beginning of this, then of course you would have inserted a geometrical set first and then started building all your reference elements in there. But very frequently you don't know, and so you just start going to town. Now what you can do, though, it's pretty easy enough. If I just cut and paste this, as soon as you cut it out, we're going to get mega errors. So Control Z. What you can do is you can reorder, and a lot of people maybe don't use this. You reorder it, but what you can do is you can say, I don't want it after or before, I want it inside. And so again, a lot of people don't know what the inside, before and after makes sense, but the inside means inside another feature like a geometrical set. And so if you go ahead and you do this, it will move it basically at one step, which it doesn't give CATIA any time to figure out that there's been an error. So that's great. So that's moved into the geometrical set now. Now I can take my line right here, line 1, and I will do the same thing. I'll reorder that inside geometrical set 1. Incidentally, that line, I would have had to have done that, moved into a geometrical set because of the time awareness of a regular body versus the non-time awareness of a geometrical set. The line was created after my sketch here, so if I would have went in to edit the sketch, it wouldn't have even seen the line. But now it's all good. One last thing that I like to do, I'll go here whenever I make a feature like this, I will go ahead and change it from, to like an axis line type, and possibly even give it a color so it stands out nice and bold, and you know what's going on. So then getting back into the sketch, now we can see, we turn it here, you can see it a little bit better, but there's our line that we just created, and we can use that to base our angle off of. So we'll flatten this back out, we'll grab our constraints, we'll pick this, make sure you don't get anything else. If you want to, pick it way up there, and we can go ahead and make this 45 degrees. Bang. And then as you notice, our math was good. We're right smack on the corner of that square. Last thing really quick, might as well put on a dimension on our diameter there. The data sheet says that it's 4.5 millimeters. This is going to be a through hole. We're not tapping it or anything. We're just going to put a nut on the back. So we'll go ahead and change this to 5 millimeters, call it good. Exit out, and then we can pocket this through up to last. All right, so what we're going to do is we're going to take pocket 3 and we're going to pattern it, do a circular pattern around here. Okay, so the here is our reference direction, and the thing to think about in this case, like in all the others, is what are we linking to? What are we choosing as a reference direction? So for example, if you use your z-axis or your vertical, one of the axes in your sketch, it's going to again create a link that we don't want to have. So what we're going to do is we want to pick some feature like this wall or this one here that we can spin it around that's relative to the power copy that we're creating. All right, so which one do we pick? So next problem, it's kind of a small one. Which one of these features is more likely to stay around rather than the other? So the thing that I haven't mentioned is when we go to place this, it's going to explode all these features out just as they would be in the tree here, as opposed to, say, having one item in the tree called power copy. So you will see these in the tree. They will place them all in the tree, and then it gives you this extra added bonus of having something like, say, a power copy that's got 10, 20 elements to it. You could place this power copy into the tree knowing that you're going to get rid of a few of them, because it's still easier to do that than it is to create the 10 or 20 or whatever, bunch of the elements to begin with from scratch. Okay? So having thought that thought, this feature, I would say, the recess here, is the one that's more likely to be deleted than, say, the through hole for the axes of the axle of the motor shaft. All right, so I'm going to choose by a margin this one right here. All right, then we come up to here and we're going to change this to a complete crown with 4 of them. Hit OK. There's our pattern. There's our part. So now we're done with our power copy. We'll go ahead and we'll save this. The thing that you don't have to do is you don't have to save this as a power copy. A power copy is just a regular CATIA cat part. It's not like it's cat power or something. So that part's done. The next thing we have to do is find our power copy toolbars, and I can tell you they're going to be down here in the bottom. So come down here to the bottom. You see you got a double-headed arrow, so that means there's more stuff there, and start pulling toolbars out. So you start pulling them out, and here we go. So what you're looking for is this toolbar here, and under this we have create a power copy, and we have a handful of different items here. Save and catalog. And over here is instantiate the power copy. So you can instantiate from document or from selection. All right, so we're going to come up here to create a power copy. Come over here, we'll add in all of our elements. So if I click Pocket 1 again, there are our inputs right here. And Pocket 2, I click that. Pocket 2 gets added, but there's no new inputs. Pocket 2 has all the same inputs, or well, at least there doesn't need to be any more than what we had for Pocket 1. Now Pocket 3 has the addition of Sketch 3 and Line 1. Remember Line 1, we used that. That's this one right here, the green one, so that we could make our 45-degree angle. And then lastly, our circular pattern. Circular pattern doesn't bring in anything else. All right, so we're basically done, but I want to explain here that over in our new part, whatever new part that we're going to be placing this thing in, all of these inputs here are going to need to exist. That is the key point to all of this. The part that I think a lot of people miss. You can't just take your power copy and stick it in somewhere where you don't have these inputs. It's going to try to make a connection, and if you can't, it won't work. Okay, so we'll go ahead and make it, but we'll come back to this in a second. So I hit OK. And then over here in the tree, again, as I said, it doesn't make a new part or anything. It just adds in a new section here, a folder, if you will, with our power copy underneath. All right. Now, as you see power copy 1 here, this is in kind of a folder, right? So the reason for this would be that you could add in more if you wanted to. You could have one big block that you make that has all of these different power copies on it that you've made for common features that you use. So we're getting close. That's essentially all of the preliminary information complete. At this point in time, you would typically save it and then close it and store it somewhere where you can come back to it whenever you need. Now, this button up here, these two buttons here, are the different ways that we would instantiate them. So if we instantiate from document, that's all this means is you're going to go open up, it's going to open up a browser window, and you're going to go find the part in your tree structure somewhere in your computer, and then you're going to place it, instantiate it. The other one here is instantiate from selection, and that means purely you already have this open in CATIA, and you're going to come back and you're going to pick it. For whatever reason, if this is open and it's saved, it won't let you place it instantiate as in using instantiate from document. All right, so that's just the difference there. I'm going to go ahead and instantiate from selection because I want to leave this open so I can come back to it. So I come over here and I pick this shape right here. So this is my new part. This is the new gantry side piece, the low squatty version of it. And we want to place our motor mount somewhere in here. All right, so we bring up our power copy again, and we go, okay, well, I want to instantiate from selection. And then it turns orange, and this is kind of one of these common CATIA type buttons where it doesn't really pop up in a window for you. It just sort of sits here being orange, and you're supposed to know what to do here. So if you look down here at the bottom where my mouse is kind of wiggling in the status bar there, it'll say select the reference to instantiate. Now people that are kind of new to CATIA, they don't understand that you can do this. They're looking around here, where do I go? Well, what you do is you switch windows, and now I can go to my NEMA 24 power copy, And you think you left the thing, and so it would forget about what it was doing. But if you come over here and you pick power copy, not this, but this, then it goes, oh, that. Okay, we'll bring that in. Now, this is the somewhat tricky part. This is the part that can cause people a lot of grief. So here is your inputs. These are all those things that we saw. Face 1, vertex, sketch, line. All right. So what it wants over here, it just wants us to click what is considered the replacement for face 1. Could this line be the replacement for face 1? Well, it won't even let me pick it. It needs to be a face. So you go, okay, what's the face that this is going to be on? This face. Click it. Great, we have it. Face. Now, which one is going to be the replacement for vertex 1? The thing that we based the initial hole off of, the positioning of it. Well, that's going to be right about here somewhere. But you see, there's a problem. We don't have it. So this is the deal. There is no vertex. We don't have any sketch 3. We don't have any line. We've got none of this. So we have to create it first. That's the problem. Let's go ahead and open up the part body here so we can see what's happening. Now, I guess we should start with the point first. We need a point, and then we need to have a line coming off of that. And that should really do it. As long as we make the point has got to be the sketch, right? Looking back, I should have made the initial point not a sketch. I should have just made it a reference point, incidentally. All right, so I'll pick sketch, and I'll go into the top face. So that just defined a face, by the way, and that's okay. That's the one I wanted. Then I'm going to place a point here. So you place the point wherever you want. Remember, we measured it off the top and side edge. I'm going to go ahead and leave it right here. It's about in the center. Exit done. So there's our point. And then we're going to add a reference line. So we'll hit this. We'll pick our point and direction. The direction is going to be, again, we chose the side edge of a line thinking that that's the way we would want it. We'll go ahead and do that. Then we hit OK. So there's our point, there's our line, we have our face and the sketch. So we should have enough now to place or instantiate the power copy. So we go ahead and pick instantiate from selection, flip windows, come over here, grab power copy 1, and now we can come through here, we pick our face, pick the vertices right there, pick our sketch, which is over here if we want to do it that way, and then the line is right here. No problem, looks good. Hit OK. Boom. And there's our power copy. In a nutshell, that's done. That's our purpose. That's what we wanted to do. Imagine that you had a feature like this that had a lot more features. You have some kind of an element here that you place on all your parts. It's got 10, 20, 30 different elements to it, and you find yourself having to recreate that over and over and over again. Sounds like you need a power copy. So you make one of these, you store it somewhere in your file system, and you tell everybody that you work with that this is where it is, and anytime you need it, you just instantiate it. Pretty cool. All right, so that's the idea. That's it, but I want to do one more thing here. I want to show you how to modify this and move this around. The way it stands right now, I could go ahead and pick that point, so I could go to that point sketch 9, and if I grab that and I just move my point down here, look at that. Everything moved because everything, all links, all inputs, everything, constraint that we made, it's all tied together relative to itself here. That's such a big thing to remember. Do it again. Grab it, move it up here. Move it over here. Maybe you want it up just there. There you go. All right. Now, if you look over here in the tree, you'll see what I was talking about earlier. Our power copy is still just a bunch of regular CATIA elements here. So if you want to edit any one of these, if I want to find this recess here, for example, if I want to double click this and edit it, there's nothing special about it. It's not tied, linked, or anything to anything else. It's just a plain old pocket. So if I want to change this to 5, no big deal. So again, you can have your power copy with a bunch of elements in it, and you could delete certain ones if you didn't need them, and it'd still make it maybe helpful to make a power copy. Or knowing that you can edit them, you could have a power copy based upon all these different types of features that you could be using, but then after you instantiate it, then you just come back through the tree and you modify them. Pretty cool. Let me show you one more thing. So what if I decided that the placement of this thing was great? I can move the point around and that's all good, but what if I want to rotate it? What if I want to rotate the thing? Well, I could just come in here to this pocket where I went here, and here's this angle. I could change that. This would for sure be one way to do it. I just twist that. Now it's tilted. But I'll undo that. What I want to show you is, what if this line that we use for straight up and down, what if I have that already at the angle that I want, or the angle that I want this to be 45 degrees away from? Okay, so let's do that. Alright, so I've rewound this back to before I placed the power copy. I just have the line and the point. And I'm going to do a couple things here, make this a little bit smarter. I'm going to take sketch 19 and line 1, and I'm going to reorder them into this geometrical set right here. Get them all contained here. Sometimes I like to put them in a geometrical set for no other reason than I get to hide them, so I can hide them way easy. So I have those. I'm in the geometrical set. Now I'm going to make another line. This line right here is going to be a point, or an angle normal to curve. So I'm going to pick the curve first, then I pick my point right there, and then I need to have a support or a face that it's on, and in this case the top of this is going to be just fine. So then we get our line here, and if we want, we can change the angle right here. For right now, I'm going to leave this as 45, but we're going to do something different to this in just a second. So I hit OK, then we're done with that. Alright, so I'm going to come up here, I'm going to define part body in work object, otherwise we'll have some problems. Then make sure you click on the background, or otherwise it's going to try to instantiate from something else. And so then pick instantiate from selection again, bounce over to your other window, pick your part copy. Now, same thing again. So we're going to pick the face, we pick the vertex right there, and the sketch is sketch 19. And then our line now is going to be this one right here. So you pick the line that has the new angle, and there you go. So now our part is 45 degrees away from this line instead. So that's pretty cool. One last thing, and this is kind of a prelim to another video that I plan on doing here in a little bit. So if you look over here in the tree, we already have an item called parameters, and that's because, well, there's a parameter added, but also there's an options button that you have to check for it to even show up. So if I come down here, I can hit this. This is all the parameters, all the things that are happening in this part already. So I'm going to say a new parameter type, but this particular one is going to be an angle. I'll hit that, and I'll give it a name, and this one will just be called line angle. How about that? And for starters, I'll make it 45 degrees, what it is already right now, I guess. You don't have to do that. So then I hit OK, and now in the tree I have a thing called line angle. This isn't doing anything whatsoever. If I double click it and I make it 30, nothing changes. If I hit it again, make it 20, or well, here, let's just put it back to 45, nothing changes because I haven't linked this to anything yet. So what I got to do is I come down here and I find line 2, and this is really cool. I love parameters. You should really use these. SolidWorks, Fusion 360, they all have things like this in there that you can use. So what I do is I come over here to angle that says 45 degrees, and it's all you have to do is this. I hit equals. I hit the equal sign. And then I hit enter, and it says what is it equal to? Select the parameter to associate to. So I pick this one right here, and now you can see that it is controlled by a formula here, or in this case a parameter. Hit OK. Great. Now they're linked. Now watch the power copy. So I double click here, and I'll make this 30, and now it changes. Now I hit it, make it 20, it changes. Right? So this is a really cool way to be able to add in any kind of quick change functionality to your part. It allows you to actually kind of manipulate it a little bit to where you can see what it'd look like without having to pop into a sketch, pop in and out, and kind of try to recognize whether or not anything really changed or not. So anyways, that is it for power copies. I hope that you learned something from that. I hope that you try these things. I think that power copies and a few things like it, formulas, parameters, are kind of daunting for people, and they try to avoid them, So try this. Try getting used to it. Find some feature of a product that you use at your company or wherever that you could maybe take that feature out and make that into a power copy. Start something somewhere simple, save it, and see if you can begin to try to instantiate in different places. And I think you'll find that once you get used to it, you'll save yourself a hell of a lot of time. So anyways, thanks everybody for watching. That is it. I'll see you next video.